Good morning, everyone, and welcome to our Coffee and Conversation on Adaptive Signal Systems. Just about a year ago, the T2 Center, in partnership with ITS Connecticut, started to advance some educational sessions on adaptive signals. This is actually our third opportunity to come together as a traffic signal community in Connecticut, and we also welcome our colleagues and visitors from states around the country. To talk about experiences about adaptive signals as you begin to make your decisions about your signal systems moving forward. We have a fantastic panel today. I woke up so excited about today's session. I'd like to introduce you to our panel, and then I'm going to turn it over to our first person. What's going to happen in the session is that each of our panelists will talk about their experiences in their states, and then we're going to open it up for the Q&A. During the course of the presentations, I really encourage you to drop questions in the chat. I did have the opportunity to get some questions in advance from those that registered, and I'm very grateful for that. So we'll start with those questions. But I do first want to hear from each of our panelists about the experiences that they're having and kind of plans for the future about adaptive signals. So first, I'm going to introduce you to the whole panel, and then I'm going to turn it over to our first speaker. So our panelists today are Kelly McVeigh, who's the Executive Manager, Bureau of Traffic Engineering, South Division of Traffic Engineering in the New Jersey DOT. We have Steve Gault, who's the Chief TSMO Arterials and Planning Section, Highway Safety and Traffic Operations Division for the Pennsylvania Department of Transportation. We have our very own Gabriella Circosta-Cohee, who's the Town Chief Engineer of Greenwich, Department of Public Works Engineering Division. We have Harold Haldecker, Principal Engineer, Bureau of Highway Operations for the Connecticut Department of Transportation, and Kevin Don, Transportation Engineer, Bureau of Highway Operations, Connecticut Department of Transportation. So I'm going to turn it over to Kelly, who's going to kick us off with a presentation of their work in New Jersey. Hi, Kelly.
Thanks, Donna. Let me go ahead and share my screen.
Just put it in.
Okay.
There we go. Looks good.
All right. So thanks for having me on the call. As Donna said, my name is Kelly McVeigh. I work for the New Jersey Department of Transportation Division of Traffic Engineering. And, you know, we've been working with adaptive traffic signals for some time. So back in around 2013, 2014, New Jersey DOT started to invest more time and energy into the research into adaptive systems, and then ultimately designing and constructing and operating them. Something that I wanted to bring up in this call, which is good to think about when you think of adaptive traffic signals, there's really two, I picture it as like two different paths that can work simultaneously. They don't have to necessarily go hand in hand, but as you scale up, it's important that you keep track of both of them. And that is the program side of things. That's the staff capabilities, maintenance resources, the funding that's available, as well as the technical side of things. So the standards that you would want to develop for sample plans, details, specifications, going through a systems engineering process for how you would develop a traffic signal system. And it takes time. It definitely takes time to do this. We are just short of 100 signals in the state of New Jersey that are under adaptive signal control right now, that are under NJDOT jurisdiction. There are more signals throughout the state under jurisdictions of other agencies that have started to deploy adaptive systems. But you can see there that, they're in several locations throughout the state. The signals or the corridors in red are what's the existing adaptive operation. So we have 4 corridors that we have, totaling just under 100 signals. And then we have more corridors that are currently in construction. So there's 5 corridors that are in construction, which is going to essentially be doubling the number of adaptive signals that we have. And then we have another 9 carders that are in final design. We also have carders that run traditional traffic management software, but that's just, for informational purposes. I didn't show it on the map. Um, the program side of things is really going to come down to um, understanding what the requirements are for operating a system. So when you've deployed an adaptive system, it's not as simple as okay, it's a system that's going to run autonomously on its own, and then we don't really have to come back and manage the system or monitor and operate the system actively. You definitely need to think about actively operating and managing the system and maintaining it. When you're deploying an adaptive system, you are now increasing the instrumentation on the roadway. You're deploying more detectors, you're deploying different types of controllers, you're requiring certain communication mediums, whether it be wireless or whether it be fiber optic cable. In New Jersey, we have found that fiber optic cable is it's the best form of communication to the signalized intersections in the field. And these are just additional pieces of infrastructure that need to be monitored and maintained. The system that we've deployed primarily in New Jersey is SCATs. We have some experience deploying InSync as well. The decision between one system or another is really going to come down to, I think, primarily agency policies. So whatever your policy is regarding how you want a traffic signal to operate will, I think, really inform the agency on what system they should pursue. What should they specify? And I'll give you a very specific example. So if you're going to deploy a system like InSync, the algorithm for that system relies heavily on non-sequential phasing of an intersection. The best it's going to run is if you allow it to run non-sequential, meaning if you have 3 phases, it can essentially go phase 1, then 2, then 3, or phase 1, then 3, then 2, or 2, then 3, then back to 2, then back to 1. In New Jersey, we provide a lot of regulatory signage related to signal phasing at the signalized intersection. So there's a driver expectation piece of it. And so we actually had to restrain or constrain, I'll say, the InSync system here. And it didn't operate as best as we were hoping when we initially deployed it. We've now transitioned to deploying more SCAT signals. There's, only so much I can say in about 10 minutes. I will give you my experience with SCATs is one that is, the system is very, what's the word I'm looking for? Detailed. It's very detailed in that you can really get it to do some unique operational things, but it requires a very, very high level of expertise on how to operate that system. If you're first deploying a system like SCATs, it's going to be a long learning curve on how you can best operate that system and not let it just kind of do its own thing. And suddenly you're thinking, well, it's not optimizing the offsets the way I wanted it to, or it's not providing the splits to certain side streets the way I wanted it to. It'll take some time for you to really learn how to use that system, as opposed to, again, using my own experience, a system like InSync, which is much, I would say, much more user-friendly, meaning there's less features to it. There's less data objects that you can change. It's kind of like you give the system some high-level parameters, and then the system will just run its algorithm. And so in that case, it's a little bit more user-friendly. The downside is it's more difficult to get a system like InSync to really fine-tune the operation the way you would want it at a signal, at least in my experience. And other things to think about are detection requirements. So another benefit for the system we deploy here, which is SCATS, is that it's detector agnostic. Now it requires a certain size of detection zone because of the requirement for capturing headways between vehicles. So you can't just have large, a 60-foot detection zone in congested conditions or saturated conditions just won't work well with a system like SCATS. It would require a smaller zone, like a 6-foot zone. But whether that be from radar or a loop, induction loop, or an image detector, that doesn't matter. So it's just an input that goes to the controller versus other systems like, again, just my experience, InSync, that required an image detector. InSync wants to estimate a queue. It needs to be able to see the vehicle. So there's some video analytics built into that system. So that's something to think about as you're investigating which system to deploy. I know I only have a few minutes left. Just going back to the program side of things. In New Jersey, we have developed an arterial management program, and the center of that is what we call the Arterial Management Center. It is like a specialized traffic operations center where we go through staff augmentation, consultant support, as well as through that contract, we have the vendor support for the various systems. And so that is a 5 days a week, from 6 a.m. to 8 p.m. operation where they are monitoring the systems, or monitoring incidents. They're making recommendations on how a system can be, certain parameters can be revised to address certain issues if they see travel time degradation on a corridor, or they're noticing significant queuing on a certain approach. They will then collect all the data. There's tons of data to pull from various systems, including the adaptive systems themselves, and then providing that information to NJDOT engineering staff to further evaluate whether or not we want to make an adjustment to a parameter in the system. And so, that was something that we moved forward with. We had a pilot AMC program about 2 years ago, and then we moved forward with it last year. And I could see this being perpetuated as long as we want to have adaptive systems in operation in New Jersey. We're going to need a program like this in place, so that somebody understands what's the detector health going, what's the status of detector health, communication to signals, and how's the system operating. I think with that, that's my experience here in New Jersey. I'd be happy to answer specific questions later, but I appreciate you listening and thank you for your time.
Thank you very much, Kelly. We're going to turn it over now to Pennsylvania and have Steve talk about their experiences. Thanks, Steve.
All right. Good morning, everyone. I am Steve Gault with the Pennsylvania Department of Transportation, and happy to be here today and talk about what we've done with adaptive signals in Pennsylvania. A little bit of overview on our traffic signal systems here in Pennsylvania. We have almost 14,000 intersections with traffic signals, and about 800 of those or so have adaptive signal technology currently. The map here is color coded. You'll see that a lot of the dots are the same color. That's the system we've had the most experience with, which is InSync, similar to what Kelly was mentioning. One thing that's unique about Pennsylvania is that almost all of our traffic signals are owned and operated by the local governments. So we have almost 1,200 different local municipalities that own and operate the signals. And our role at the state is we issue permits for the operation. We usually are assisting with the construction phase of the original installation, but once it's installed, then the operations gets turned over to the municipality. So their input is very important in the process for us. In terms of how we got to where we are now, really trying to understand where we had challenges with our signal operations program before. With all those municipalities, there was a lot of desire for addressing things where they may not have resources to do as much from an operations side. Vendors are always bringing new products to the market, and when they come up with new products, they always say that that's going to solve all of our problems. But one of the things we're learning along the way is that we really need to make sure we're defining that problem well. And it's easy to be, to use a term from Rick Denny at FHWA, it's easy to be seduced by the technology and sometimes figuring out, do sexy toys make the funding decision makers want to fund our projects? So if we use enough buzzwords, will we be able to do a project? And sometimes it's hard for others to say no to that, even if we know that it won't necessarily accomplish what we wanted. So when we look back at some of the things we've done in the past, we've done things like closed loop systems, even things like preemption for emergency vehicles. Have we really met those needs and solved the problem that we're trying to solve? So we've really tried to improve our systems engineering process, and it's really trying to find that sweet spot between the complexity of a full-fledged systems engineering process and minimizing the risk of putting a lot of money and resources into a system and not having it achieve what we wanted to set out to do from the beginning. So there's always going to be a trade-off there. A few dollars up front can be helpful to not end up with more costs down the road. And it's also important to understand that reducing the risk doesn't necessarily make the project cheaper, but being cheaper is better than being unlucky. So again, we want to make sure we're understanding those needs, defining the problem before we implement the solution. And it's really where engineering, management, and the application domain experience all come together with all the different stakeholders, whether that be the operators who are going to use the system, anyone that it'll impact, such as those that are doing maintenance, even the political stakeholders from a management standpoint. So the Federal Highway Administration had developed some model systems engineering documents for adaptive signals, and for Pennsylvania, we tried to simplify this, and we came up with this 6-page checklist, which we call a Form TE 153, and we're seeing that we may have oversimplified it, and that's led to sometimes our projects not delivering on what we want. So we're trying to find that sweet spot still, in terms of maybe introducing a little more complexity to help reduce the risk of the projects not meeting the needs. So with that in mind, we're starting to work on a toolbox for selecting signal systems. So in the past, it was a very adaptive focused process, but we're trying to expand that to consider a full range of signal operation strategies. So the end goal here is to have something similar to an intersection control evaluation or ICE process, but at a corridor or network level. So some of the examples of strategies that might come out of this process would be something as simple as just a fully actuated signal in free operation, actuated coordinated operation, maybe pre-timed, adaptive is still in the mix, and then even considering traffic responsive, one of those older technologies that didn't always get fully utilized. And our toolbox is really looking to build a step-by-step process, and if we get to the end of stage 1 and there's only one obvious direction to go, then we don't need to continue through all of the details in the later stages. And some of the factors that we might take into consideration are that timing optimization is really going to be most effective when there's a range of signal timing that would be appropriate. For example, if we can change the cycle length a lot, otherwise there's not really much room to optimize the timings, and we're not likely to see much of a change in performance. So some of the constraints that we're factoring into this are pedestrian crossings, recognizing that the amount of time for pedestrians to cross can limit how short we can go with the cycle length. And if we have enough pedestrians that becomes a factor, we don't want to make the cycle length too long, which leads to pedestrians making unsafe choices. The number of phases can also be a factor there. The more phases, the more clearance, the more lost time, that's going to lead to longer cycles. And then something even as simple as if we have a one-way grid, there's really probably one set of optimal timings to keep traffic moving in both directions on that grid, and it's easy to do progression with one-way streets. So that probably wouldn't be an adaptive situation, probably more of a pre-time type solution. And then the other factor we're considering is the agency capabilities for maintenance and operations. So we're not introducing technology and a burden on those local municipalities that have to maintain the system that's beyond their capability to do that. So there's a lot more detail. There's a link here, and I'm assuming we can get the slide shared afterwards to a TRB paper that goes into that in more detail on what we're doing. So some of the lessons we've learned, making sure that there's that plan for long-term maintenance and operations. If it's not there, the original operation will start to degrade over time. As we've seen with some of the older closed loop systems, we've had some challenges with adaptive systems where there was a warranty for some of the initial years, and then there wasn't a desire to pay for keeping it operating beyond that. The vendors are really a key piece in deploying an adaptive system. So they're the ones that are going to know how the system works. And depending on the system, the signal timing engineers may have more or less ability to turn the knob, so to speak, and manipulate things when they're not operating as desired. So sometimes that leads to essentially having to outsource that signal timing to the vendor. We've had some challenges with doing the validation and verification to make sure that does get completed, to make sure that we're meeting those objectives. Pedestrians and preemption can really impact the operation. Detection is the most important thing, no matter what system you choose, because that's really going to be determining those inputs that lead to how it's going to do the optimization. And then, like I was mentioning, the maintenance is also important. So I think that's about my time limit here, and we can move on and then get questions at the end. So thank you.
Thank you, Steve, very much. Next, we're going to transition to our chief engineer from one of our local municipalities to talk about their experiences in Greenwich, deciding on and utilizing adaptive signals. Thanks, Gabriella.
Thank you. I'm going to share my screen. Is it sharing correctly?
Looks good.
Okay, thank you. So good morning. My name is Gabriella Circosta-Cohee. I'm the Chief Engineer with the Department of Public Works Engineering Division in the town of Greenwich. I'm excited to be here and to have been asked to be part of this conversation with others that are interested in this fairly new traffic technology. From the municipal side, I'm going to go over our experience with design and implementation of adaptive signal control technology along the Arch Street corridor in the town of Greenwich. So the town owns and operates all traffic signals in town, including those along Route 1. When DPW embarked on this project several years ago, it started actually in 2012. We knew that there was significant traffic in this corridor that was due to the train station, the I-95 on and off ramps, The proximity to downtown, the Bruce Museum, Bruce Park, and especially Roger Sherman Baldwin Park, which hosts many high traffic volume events. In a corridor used by approximately 35,000 vehicles a day and growing, we knew we had to look into the future to see if there was new technology that could be used to improve traffic flow, especially queue lengths at the I-95 off-ramps, decrease travel time, reduce congestion, and lower vehicle emissions. A CMAQ grant opportunity came up about the same time, so we jumped on the opportunity to submit an application, and we were awarded the project. So the problems we saw here were the queuing at the I-95 southbound main line, the Arch Street queuing at I-95 northbound, along Arch Street for the entire length. Existing signal system was unable to handle the I-95 incidents. Sometimes there were closures, and it was just mass volume, especially during peak times. And the train station arrival departure demands. So in reviewing several different options, we decided that adaptive signal control technology checked all the boxes. Unlike traditionally timed traffic signals, adaptive signal control technology accommodates challenging traffic patterns and calculates a traffic signal timing plan based on the changing traffic conditions on the roadway caused by traffic crashes, special events, and road construction and other roadway incidents in real time. We were excited to find out that the new adaptive signal traffic system is able to detect an influx of vehicles and improve the traffic congestion by instantly adjusting the timing of the traffic lights at all 5 intersections. So once we decided we were going in this direction with the design process, with this project utilizing the CMAQ grant funds, it involved the installation of new adaptive signal control technology along the corridor, the replacement of mast arms, control boxes, PED signals, sidewalk sections, pedestrian ramps, replacement of a signalized driveway with an RRFB, installation of a full fiber network, and new signage. So it was a pretty big project compared to what we're used to. The design and construction of the project was 100% reimbursable under the Federal Highway CMAQ program up to $2.75 million. Of course, with the CMAQ program, there was additional paperwork involved when it came to the design and construction process, and that was a huge undertaking. For those unfamiliar with where we're located, this is the area of the second to last or first exit, depending on how you see it, on the I-95 in the southwest corner of Connecticut at the border of New York. And so those intersections which benefited the most from this project were the Arch Street at Railroad, Arch Street at Horseneck Lane, Arch Street at I-95 southbound exit 3 ramp, northbound exit 3 ramp, at Roger Sherman Baldwin Park, where we host many events, and at Museum Drive. As for the brains of the system, all 5 intersections received a 352i low voltage DC ATC cabinet. The new traffic lights, control boxes, and pedestrian signals are now more efficient and use 66% less energy, which is one of my favorite advantages of this project. These cabinets contain the latest technology needed to run the signalized intersection, including battery backup. Each traffic control box communicates with each other in real time through a fiber optic network, which was also installed as part of this project. This project also introduced the first yellow flashing arrow in the state of Connecticut. The flashing yellow arrow is a new type of signal located in a dedicated left turn lane at a signalized intersection and signifies yield to oncoming traffic and then proceed with caution. This alleviates traffic and queue time by allowing vehicles to turn when there's no traffic in the opposing direction. Prior to the flashing yellow arrow, motorists had to wait for the green light to make that turn, which had contributed to incredible backups in this area. MyoVision cameras were installed on the traffic signals, which serve the purpose of collecting and analyzing traffic data on directional traffic flow, vehicle delay, and lane queue length. These cameras can even detect if a pedestrian, bicyclist, and the type of vehicle, whether it be a car, SUV, truck, tractor, trailer, are traveling through the intersection. The McCain Transparity Adaptive software, which is what we use, it receives the traffic data from the controllers, and the signal timing is adjusted and improved based on the data received. Since this technology is steadily monitoring the roads and traffic flow is consistently modified depending on traffic patterns throughout the day. Our experience to date has been mostly positive with adaptive signal control technology implementation. It was the first unseen improvement, as the implementation has been mostly behind the scenes or in the controller box and cloud, and not visible construction, as is the case with a lot of our other projects that I'm involved with. After the installation of the new mast arms and control boxes and fiber network, public comments were consistently with your state-of-the-art technology isn't working, but our responses prior to it functioning was, well, it hasn't really been implemented yet. We didn't flip the switch yet on the ACT. So once it was all installed and after implementation, of course, there were no complaints. We did receive a few compliments. We liked it so much, we decided to pursue in the installation of adaptive signal control technology along Route 1. The final design was just completed, which will include adaptive signal control technology from the New York border to Stamford. So hopefully this time next year we'll be in construction with those improvements. As for lessons learned, it's important to know that it's what is compatible with the controller standard in place. Not all adaptive systems are compatible with certain controllers at that time. It's important to know upfront which technology will interface with the municipality's existing traffic operations system. In addition, it's important to understand that ASCT is not ideal for all locations and shouldn't be looked at as the initial go-to for solving traffic issues. A proper review of the existing conditions should be assessed before deciding which way to go. There were some challenges when deploying the system and a bit of a learning curve for our staff responsible for the signal operations. There was a great team involved in this deployment, and it was ultimately a successful project. Post-implementation, our police department was used to the old way of overriding the signals during large events with high traffic volume. So being that the adaptive is designed for these events, it was difficult to communicate to them to just let the signal handle everything on its own and just be stay out of its way. So that concludes my presentation. Thank you for the opportunity to share our project with you. I was fortunate to have been trusted with this project from beginning to end, and lucky to have a great team involved in this project, from urban design and inspection team, Nikon, and District 3 at DOT. So we're excited to be a leader in implementing new and advanced infrastructure, which can decrease the vehicle emissions and improve air quality. Thank you.
Thank you, Gabriella. Really appreciate all that great information. And now we're going to turn it over to Hal and Kevin at the Connecticut DOT.
Hi, good morning, everyone. It's really exciting to see such a great turnout for this coffee and conversation. Just wanted to provide a brief background for Connecticut DOT. Our agency has been operating computerized traffic signal systems since the 1980s, using mostly time-of-day operation. We did some early traffic responsive operations in some corridors, but we just weren't satisfied with the results since the responsive did not sufficiently modify timings to traffic demand that was in place. We especially noticed that it just didn't adjust the timings and offsets to react to changes in directional traffic flow. So we stuck with time of day plans for many years. We spent a lot of time fine tuning the plans and performing periodic timing plan reviews on a system by system basis. We were familiar with that other agencies were implementing traffic adaptive. It was always of interest to us, but we just didn't have the required infrastructure that we needed to run adaptive or to try it. That included things like full detection on all approaches and high-speed communications between the field equipment and the central system. But recently, we were able to upgrade a lot of our signals to the latest standards. We're in NEMA state here in Connecticut. We have about 1,000 computerized signals right now. And we were able to get our detection systems, communications infrastructure, our central control system updated. And we were also able to bring on board some technical staff to help us really begin a trial implementation of traffic adaptive. So our first traffic responsive system implementation is Route 15, the Berlin Turnpike, which runs in front of Connecticut DOT headquarters. It's our test bed for new technology on signals. We turned on the adaptive system last year. We also used West Street and Rocky Hill as a trial system. That system was updated a little bit before Berlin Turnpike, and the advantage of West Street is it's right in front of the traffic signal lab, so we had technical staff nearby to keep an eye on things. So at this point, I'd like to introduce Kevin Don. Kevin manages our CTSS program for our agency, and he's going to provide more information on our experience with traffic adaptive. So Kevin.
Yeah, can you guys all hear me? Assuming that's yes. I like how I mentioned there was a pilot project for adaptive.
Kevin, I forgot to mention that you're joining us from Phoenix, Arizona today. You're out at ITS America, so thank you for joining in here.
It's all good. Yeah, like Hal said, 7264 involved the implementation of adaptive as a pilot for Connecticut DOT. It also included ATSBMs, CCTVs, and connected vehicle technology. And like all adaptive systems, we had to make sure we are putting detection. Detection is very important for the adaptive system. It also included other things like protection accommodations that you guys see on the screen, and the necessary fiber connection, recommended fiber connection for adaptive. Like Hal said, we had a project purpose. We wanted to reduce travel time along the Berlin Turnpike, possibly decrease emissions, improve signal reliability, improve pedestrian mobility, and so on. We wanted to test adaptive before going on the Berlin Turnpike, and we tried it in front of the lab. We initially put it at 6 locations, but now only 4 is actively being used. And this is based on the time of day operations versus the need for diversion of detours if we ever needed to. As we got going with the Rocky Hill, we went on to put an adaptive on the Berlin Turnpike as part of the 7250 project. Once, of course, construction activities was complete, we had the necessary detection, communication infrastructure. We started with the adaptive implementation. There are 2 subgroups right now based on the adaptive deployment. As you guys can see, there's subsystem A and subsystem B. And the grouping is definitely important, as we saw, as we are continuing to see, because intersections can be impacted if there is potential changes at a main intersection. So our path to adaptive was not easy. There was initial steps that we had to do, and this all started when we started our Rocky Hill project, Project 118-170, and Project 118-185. that was completed in 2020. That included the upgrade to fiber interconnect from copper interconnect for the Rocky Hill systems, establishing a fiber connection from HQ to the signals into our signal lab. Of course, we also found out that our server was outdated and we needed to update the server. Racks, pay for the operating systems, pay for the switches, pay for the cores, pay for software licenses and necessary power connections for that server to operate to run the new software of ATM now. This also included communication upgrades in the head-end, both from the admin building into the lab building, and also upgrading the Cat3 connections at the lab to the Cat6. We also purchased improved, better computers and field equipment laptops so that the lab can be able to do what they have to do to manage our systems. Of course, there was also upgrade the non-intrusive detection technologies, two non-intrusive detection technologies, and then installation of ATC controllers for all 19 locations in Rocky Hill, and the typical signal upgrades, which includes crosswalks, spans, mass arms, etc. And then we also had to go through the process of procuring ATM now. We identified that there are recurring costs, maintenance costs associated with software. This includes a special software ATM now, and of course, the software and manual maintenance fees for our server as well. Definitely a learning curve getting our signal staff properly trained, and we made sure that there was IT support and IT presence there during the entire process. There is another path to managing signals that may involve consultants hosting it, but our path was in-house. Of course, with our deployment, there was federal funds involved, and we had to make sure that 23 CFR 940 was followed. And we also, like Steve mentioned, used the model system engineering document for adaptive signal control systems. We went through the process of putting together a SEMP. The SEMP definitely needs to be fine-tuned, reviewed as we continue to go on. And if we ever decide to pursue more adaptive, we would definitely need to revise and make sure that we identify key requirements or requirements that may need to, other requirements that need to be removed. At the end of the day, we decided to use Synco Green based on compatibility and what we currently have in terms of the system that was installed. And that's it from that standpoint. Of course, with the adaptive requirements, we have to consider stuff like the server, the software. Of course, for Synco Green, we had to make sure we had ATM now, and we had to have the Synco Green licenses per the controller. For servers, we had to consider, like I mentioned before, we had an outdated server that did not meet the minimum requirements of the software. And we also need to consider going forward, if we were to deploy more adaptive, the need to back up and having some redundancy. Like everybody else mentioned, there was a need for ATC controllers, communication both in the field level for the interconnect, communication back to Central. I know Kelly mentioned fiber is recommended for New Jersey or wireless, and that we are in agreement with that approach. And we also have to make sure that Central had in equipment, both server and communications upgrade as well. Of course, again, detection is very important. And about all these, the adaptive will not function with its full capability or work to what we expect it to be. As our current progress for adaptive, we implemented adaptive, of course, after construction was mostly complete, and it started in August 2023 with coordination with the manufacturer, the signal lab, and our higher operations staff. The review is still ongoing. There's a lot of things that we're learning. Every time we see it operate, we have more questions. So it's definitely something that is not set and forget, and it's an ongoing process. You need active operations and maintenance, and we need to evaluate the need for how the signals are being how the quarter is being used. Is it used on a time of day basis, or is there a potential detour opportunity? Of course, like all signal equipment, we have to make sure that everything that is being used to operate the adaptive system is working correctly and functioning properly. Our experiences for the adaptive deployment included seeing instances of, going back a step, You guys see a picture to my right. This is our a Grid Smart camera detection zones, and you guys see that there is some occlusion that may have potentially blocked the left turn phase. Stuff like that can potentially impact adaptive. Having more detectors out there and ensuring that this accuracy allows the adaptive to run the best it can. And having more detection gives that flexibility to make sure that adaptive is running the best it can. Some experiences that and issues that we encountered was skipping phases, split failures, min-time violations, in and out of core occurrences, some inconsistent patterns and transitions. There was some confusion at the end of how our signals are designed in terms of phasings, geometric layout differences, the way the signals are grouped together, and how our coordinated phases are, whether it be phase 2 and 6, or if phase 3 was a coordinated phase or not.
Kevin, you have about a minute
Okay.
before we enter the Q&A. Yep,
Okay.
no problem.
Vendor support was definitely important, of course, and we needed to make sure that that was there. Some next steps include, like Steve mentioned, we want to evaluate adaptive. Adaptive is not the best for all locations. We want to put together a checklist following system engineering process, and we got to make sure that it works with our technology. Of course, there is Synchro Green. For our case, we have heard that there's modeling. Conda is not able to do the modeling, and the Synchro Green modeling software is outdated, not currently available. There's some reasons for deployments, as you guys can see. Availability of funding, of course, other category, political pressure, political opportunities, reducing cost of travel time, blah, blah, blah. There's also key considerations to why agencies would be putting in adaptive. That includes if they are not comfortable way for a closed loop system, why jump to adaptive operations? Are they able to operate and maintain it? And then there is difficulties for maintaining adaptive. Based on the NCHRP report 403, it's a little dated, but it's more demanding to maintain traffic signals with adaptive. And there's some key considerations based on the report, and that's it from my end.
Thank you so much, Hal and Kevin, and to all of our speakers. Such great information. I appreciate how you captured it in such a short period of time as well. I will remind the audience that this is all being recorded, so all of the presentations will be available to you to review again later. I do want to take some time. Thank you so much to the speakers for adding the answers to some of the questions already in the chat. Thank you. That was very helpful. I will just kind of throw a few questions out, and any of our panelists are welcome to answer these. These are ones that were sent in advance, so I think that you've addressed bits of this as you've gone, but if there's anything else you want to mention on it, feel free. The first one was, where should adaptive signals be used versus actuated signals? That was kind of one of the things, and if the person who submitted that wants to add anything else to that question, feel free to unmute. If you all feel like you've addressed mostly your decision processes on that. Feel like you've covered that mostly, or does anyone want to add anything else?
Well, this is Steve. I can chime in a little bit because that's one of the things we're looking at with the toolbox that we're building. The decision on it really comes down to whether there's a desire to provide smooth flow or progression along a roadway. If it's just fully actuated and not at all coordinated, then it's likely that the signal will gap out right in front of a platoon and be what I call inverse coordination, and creating a lot of stops. So if that's the goal, then I think some sort of coordinated operation, whether it's adaptive or one of the other coordinated strategies, would be appropriate.
Kelly, you good?
Yeah, I'll just add a little bit here because I
Sure.
had mentioned in one of my responses something that I just didn't get time to really talk about earlier is like a customer service aspect to this. When you have a system, so you heard several times communication is really important. Active operation and maintenance of the system itself is important. There's a customer service aspect to that, meaning If you have a corridor, even if the traffic conditions are, you're like, okay, maybe typical optimization might be good here, but it's a corridor where for whatever reason, you're like, we always get complaints. There's always seems to be something going on. Having a system in place that you can then deal with in real time. So there's an issue right now, and 30 minutes from now, there's no issue. That to me, that is very important to consider. Other aspects to consider are just, corridors that parallel freeways, limited access roadways that could potentially be used for diversion. Also corridors in seasonal areas where you've got traffic fluctuations from Friday to Sunday that it's difficult to capture in a time of day scheme.
Appreciate that very much. So the next one is any examples of managing offset intersections? I have a corridor of 6 offset intersections that are closely spaced and involve several arterials and collectors. Is there any hope for me? Steve's jumping in.
Yeah, so I think it really is going to depend on that, how saturated it is. If you're, I'm assuming with offset intersections, you're probably looking at split phasing. Some of the adaptive systems, like Kelly was mentioning, specifically the in-sync system, can alter the phase sequence, and sometimes that will allow serving those offset approaches in a different order, which can provide some benefit, although it can also cause some driver confusion. So it's a trade-off on how much benefits in that, but it is something that can be done.
Thank you. The next one is actually looking ahead. How do you, and this might require a crystal ball for you all, but this question was, I'm anxious to understand how adaptive technologies are evolving and kind of where we see them down the future. I know in one of our meetings, we were talking one day and they were asking about the potentials for evacuation and how that might be impacted by kind of adaptive signal technologies. And I'm wondering if you kind of see some things coming that might be potential opportunities for that looking down the road.
So I guess I'll talk from my perspective, just because, so for the past little over half a decade, we've basically just been expanding our existing systems. It has to do with business continuity and, the ability to staff knowledge to be able to use these systems. But we've been looking into newer systems and getting some, presentations from various vendors. And it seems like there's a lot of, because of what's happening with like video analytics and other analytic capabilities of pulling in large data sets from, you're mentioning evacuations, well, you can pull in data sets from like, weather forecasting services to figure out when potentially an evacuation may be needed. There's a lot of development being done outside of the traffic signal controller. So you have to think about if you're going to deploy a system where you have essentially the system is isolated from the controller itself, how are you going to be maintaining the controller? Can the controller do what that system wants it to do? So a system may be capable of capturing weather information. It can count up to 100 people on an approach. It can tell you what vehicles they are, whether people are on bikes, all of that. The system's going to do all that analysis, and then it's going to right now it just has to basically boil it down to an input to a controller to be able to control the signal itself. I've been asking controller manufacturers this anytime I get the chance. I think at some point they are going to try to come up with a standard for how controllers can use analytic software, video analytic type data to make better decisions in the controller itself. I think that might be where it's going. What that means for agencies is just, I think, a higher complexity of the device that's being deployed in their cabinets.
Thank you, Kelly. Appreciate that. And I think in the spirit of time, I'm looking and there's so much great information that the speakers shared in the chat already. What I would encourage you to do is if you have a burning question that we haven't gotten to yet in the chat, how about if you unmute? And we can truly have this be the conversation piece of where we get to hear from you as well. Did anyone have a burning question that you put in the chat that you really would like to make sure is answered before these wonderful speakers head back to their day? Feel free to unmute and ask that. See, you all did such a great job. Let's see. And I know, Kate, you were asking about annual costs. I think Gabriella was talking about that. Did you have other questions as you work in Kate is with one of our regional planning agencies? Kate, did you have other questions, or did you feel like they were addressed for you?
I think that question was well addressed. Thank you, Gabrielle. Maybe I could ask you another question though, which would be, at the local side, you are more involved in land use, and one of the challenges of adaptive signals is those non-regulated curb cuts, right? So or not non-regulated, but not signalized. So all of the curb cuts within your block. Have you had discussions with your land use staff about how to manage that from a traffic ops perspective?
No, fortunately, with the Arch Street project, that was not an issue for us. Right now, we're working on the Route 1 corridor and implementing the adaptive signal control technology there. We just completed final design, and as far as I know, that has not been an issue.
Thanks.
Thank you, Kate and Gabriella. So I'm gonna ask a question from actually, Steve and Andy were having a chat in here about is anyone employing adaptive signals in a block formation or primarily in a straight line? Thought that was an interesting question. Did you want to add anything to that? Looks like you've got some good information here on that as well. I really do encourage anyone, if you haven't been looking in the chat, there's some great information that's been shared in there. And I think honestly, everyone in here has actually answered the question. So y'all are fantastic. And we are right on our time, which is amazing. I'm going to turn it first, I want to thank the speakers so very much for being willing to be part of these continuing conversations. I just think we're going to continue to offer these opportunities moving forward. And I certainly value the partnership with ITS Connecticut to do this work. Thank you all very much. I know Vanessa would love to ask you to give feedback so we can see what topics you'd like us to offer in this program moving forward. But I'm very grateful for your time today and turning it over to you, Vanessa, to close us out.
Sure, thank you. I just want to say thank you again to everyone attending the webinar. We hope it was a valuable use of your time. And another special thank you to our presenters. We hope to continue this conversation in the future about adaptive signal systems. Please take a minute to fill out a brief evaluation form to just let us know what you thought about today's webinar and what you would like to see for future coffee and conversation sessions. So the QR code is on your screen to access the evaluation, but I also dropped a link in the chat box as well. Thank you, everyone.
Yes, thank you very much. Enjoy the rest of your day. Be safe out there.
Thank you.